this as quickly as possible here. So we have the review from Tuesday is what we're taking a look at now. And all right, so on here, I'm going to try and go through all the questions, at least from the left side. I'm not going to get through everything on the back, but for the tests tomorrow, the majority of the test is multiple choice. There are some free response questions that I'm going to have you bubble and stuff again, but the majority of it is multiple choice. Now, that being said, I also tried to make it so that it was about the same level as what the first side was, the one that was multiple choice. I didn't require a lot of algebra solving on it. So I actually think that the front side of this is a decent review for what I ended up putting on the test. There is a couple more matching for the first part as far as names of things go, like for secant and for diameter. Those were asked on the first three, but again, identifying parts, there are a few questions there. So going through this, name a radius. Which one of those is a radius? And make sure you pay attention to on these first three, if it's a segment or a line, because that does make a difference. So what's the radius? It is XB. Right? XB was a radius. It went from there to there. Right? All right. The next one, name a chord. Which one of those is a chord? EC. Now, are there other chords in there? Yes, but that's the only one that's listed. AC looks like it could be a chord at first glance, but notice that it has a line over top, not a segment. So AC is not a chord because this is line AC, not segment AC. We talk about line AC. What is it? Then it continues on and goes through the circle. Tangent intersects at 1 point. What intersects at 2 points? Start with an S. It's a secant. Secant. All right. So line AC is an example of a secant. All right. The next one, name a tangent. There's only one tangent on that diagram. It is line what? BD. Yeah, tangent intersects the circle at exactly one spot. All right. Let's go to number 4. The wheel on Elliot's truck have a circumference of 22 inches. Determine the radius of each wheel to nearest length. So there's a couple formulas that we use for circumference. There was pi equals 2 pi r, or there was circumference equals diameter times pi. So depending on whether they give you the radius or the diameter, depends on which one you want to use. Now, good news is for this test, I am going to allow you to use your notes so you have access to the formulas. I'll also try and write a lot of the formulas on the board so that you can use them. Now, will you have all these formulas on the EOC? No, but I know I've had a few people out in there for testing and different things the last, especially this last week when they started doing all the FSA makeups and everything else. So if you didn't get to learn all the formulas, I'm not trying to hold that part against you. So I'll fill up the board with formulas, and then you can use your notes. You can use those worksheets that I had given you where you could write most of the equations on one sheet and all that stuff. All right, let's keep going. So they gave us a circumference of 22. They want us to find the radius. So I'm going to use that top one that I just wrote down. Circumference was 22. I'm going to do 2 pi r. We need to solve for the radius, so we need to get r by itself. Divide by 2, you get 11. Now we got to divide by pi, which pi is roughly 3.14. You could just plug this into your calculator, bless you. Now, when you divide 11 by 3.14, I don't really have to use a calculator here because I should be able to say, all right, well, 11 divided by 3 is roughly between 3 and 4, right? If I look at those answer choices, there's only one that it could be, and it's 3.5. Now, again, I got a calculator. We would have got that as an answer anyway, but remember, if you're doing a multiple choice test, which, like I said, the majority of the test will be multiple choice, use good test taking skills. I'm trying to talk way too fast. Use good test taking skills. a lot of times you can eliminate answer choices because they make absolutely no sense for the problem. So on number 5, we have circle C. Measure of arc AB is 72. So label the diagram as you go. This is 72. They want us to find BCD. So BCD is that angle that highlighted in orange. In order to find that angle, I need to know the arc across me. Well, AD, split that circle in half, so we have a semicircle. I know that a semicircle has how many degrees? 180. So all I need to do is take the 180, subtract off the 72, and that should leave me with the other arc, which is 108. And the angle will be the same. Again, that's a central angle. The angle is on the center of the circle. Therefore, it's going to have the same measure as the arc it intersects. On 6, find the length of PQ. So PQ on this one. Look at that arc. We're finding length. So now that's one of these formulas I have on the sideboard over here. For arc length, you're taking the fraction of the circle you're using. So whatever the measure is in degrees over 360 and multiplying it by the circumference formula. So on that diagram, they gave me 60. That's 60 out of 360 degrees equal, sorry, not equals. Yeah, I'm looking at myself. Oh, I'm using different tools. Let's try it again. All right. 360, that's 406. There you go. All right, times, they gave me a radius, so use the circumference formula for radius. 2 pi, the radius was 3. Now, I could simplify that first. Again, if you're plugging into a calculator, you could plug that whole thing into a calculator right now. All right. I usually simplify first. So 60 over 360 reduces to 1/6. 2 times 3 is 6. And 1/6 of 6 is just 1. So 1 times pi is going to give me 3.14, which is h. All right, on number 7. Said in circle O, AB is 12. All right, so labeling this again. AB is 12. Then it said that EO is 4. It also told me OF is 4. Well, if those two pieces are the same length, that means that the chord AB and the chord CD are the same distance from the center, which tells me what about CD? What should I know about the length of CD? It's the same as AB. Again, if they're the same distance away from the center, then they have to be congruent. So that one's going to be 12. Now, other thing that I should know, because they are asking me to solve for this piece here, CF, divide 12 by 2 because this line is perpendicular, meaning it's going to split this in half. That's one of our properties. So that piece, this has to be 6. Any questions there? Save this. Like number 6? Yeah, I would say so. Yeah, so again, that one, that's using this equation. So if you're looking for a length of an arc instead of a measure, you're doing the measure of the arc in degrees out of the whole circle, 360, and multiply it by the circumference. So you have to find the circumference. If they gave radius, you can use the radius version. If you gave diameter, use the diameter version of circumference. Then it's just multiplying those two values. And you don't have to simplify like I did on number 6. You could just multiply the whole thing out in your calculator and be done with it that way. All right. The only time you have to actually simplify is if I said leave it in terms of pi. I think there's only 2 answers on the entire test that said leave it in terms of pi. think it's 18. Yeah, again, this is one of those where if I put too many questions on the test, you definitely run out of time. So I try to keep it a little bit shorter. Clear. So we are now on question 8, right? Again. All right. Number 8. So they said find the radius of a circle if, now, did they give me a diagram on this one? No. So for number 8, I'm going to go ahead and draw a diagram over here. Here's my circle. They said that I have a radius. No, so I find the radius of a circle if a 48-meter chord is 7 meters from the center. So I have a chord that's not going to the center. That I'm going to say is a total of 48 meters. Draw my center point. It said it is 7 meters away from the center. So right now I have that as my drawing. So the chord is 7 meters away from the center. That chord is 48. They want a radius. Well, where can I draw a radius in here that I can actually solve for? This is a right triangle. So I now have a radius there. I know that whole thing's 48, so this piece has to be 24. And now I have a right triangle with 2 sides labeled. So we could use Pythagorean theorem. The radius is in place of where my C value would be. So I can say R squared equals 7 squared plus 24 squared. And again, if you wanted to use Pythagorean theorem, you can solve through that and get your answer. However, do I have to use Pythagorean theorem? No. I erased that one. I think I had that one on the board the other day. This is a triple. It's our 7, 24. And we know what the other value that's missing is? 25. All right, so let's see. What number was that? That was number 8. The correct answer on that one is 8. But again, look at the answer choices. At the very beginning of this, we could have narrowed it down to those 2 possibilities at the end. Because these 2, it couldn't possibly be. Because when I drew my diagram, the radius was my hypotenuse, which has to be the longest piece of that triangle. So the 24 was out. The 14 was definitely out. So I only had those 2 at the end that would have possibly worked. Now, if I drew it to scale like I did here, hopefully you'd see that it couldn't possibly be 41 either. Right? So on there, 25 was the only one that was within a range that made sense. On 9, find measure of ABC. So angle ABC. All right. Well, here's ABC. ABC is intersecting this arc that is not labeled. We know all the arcs in a circle have to add up to what? 360. So 360. Subtract off these other 2 values here. So subtract off a total of 220. Leaves us with 140 for this arc. What's the angle? Is it also 140? 2. So if it's on the circle, it's half of the intercepted arc. So it's going to be V. All right, number 10. On that one, you have a measure of angle X. So this one, they gave us something different. X was 126. They want us to find angle Z. Well, what do they actually have on that diagram? They have a quadrilateral inscribed into a circle. Since we have a quadrilateral inscribed into a circle, the 2 angles that we're using here are opposite angles. That for a reason. There's a property for opposite angles of a quadrilateral inscribed into a circle. Those 2 angles have to add up to what? What was it? 1. I don't know if I heard the correct number or not. So those 2 angles have to add up to 180. They have to be supplementary, they have to add it to 180. So 180 minus the 126 leaves us with 54. The answer is F. So that was one of our properties. The reason why that works is a full circle is 360 degrees, right? Anytime you have a quadrilateral in a circle, the two opposite angles, they meet at two common points, right? So on this example, Y and W, they share those points in common. This angle is intercepting this arc. This angle is intercepting that entire other arc. So together, they're intercepting 360 degrees. Well, intercept angles are half of their intercepted arcs. So if together combined, their intercepted arcs are 360, the angle measures together would have to be half of that, which would be 180. Does that make sense? No? All right. But opposite angles, just remember that fact. Opposite angles are supplementary. Okay, number 11. Number 11, we have these three angles are tangents. If you have tangents coming from the same exterior point to the point of tangency, those segments have to be congruent. So on there, if we know that this little piece is 2, what's the little piece right next to it? It's also 2. Now, on the next part, they gave us this entire line, MN is 10. If I know that little piece is 2, then that other piece on MN has to be how long? 8. Subtracted, got 8. So then what's X? X is on the other side of this. 2. So now that this is 8, what's X have to be? It has to be 8 as well. It's on the same, coming from the same exterior point to a point of tangency, they have to be congruent. All right. That's it for that half. Let's look at the other half there. Oh, whoa. Did not do what it normally does. It started going. Hold on. Somehow I changed one of my settings. All right. Number 12, right? That's where we just left off. Okay. Now we have angles intersecting inside a circle. And we're looking at the angle measures. The angle measure is going to be equal to what? What do we have to do on this one? So this is the angle that we're trying to find. We know that it shares the same measure as the angle on the other side of it. They each have an intercepted arc. We have to do something with those two arcs. The formula. It's inside a circle. That's got that chart. So if it's on the circle, we just divide by 2. If it's inside the circle, we have to do something first before we divide by 2.
Isn't it the big arc you're talking about, like the little arc?
So that's if it's on the outside. If it's on the inside, it says subtraction. You do division, addition.
Addition plus arc 2 divided by 2.
Arc 1 plus arc 2 divided by 2. Taking the average of those two arcs, you're adding them and divided by 2. So on here, we had 122 plus 68. That gives us a total of 190. 190 divided by 2 is 95. Each of those angles is 95 degrees. On 13, measure of arc VY. VY. Now, we're using the same formula. They gave us the angle. We're just missing an arc this time. So I'm going to call this arc X over here. So that when we plug it in, we can solve for it. We know the angle is already 64. So 64 equals the one arc they gave us plus the one we're trying to solve for over 2. How do I solve? Multiply first. All right, so multiply 2 out of the denominator, we now have 128 equals 48 plus x. Then what? Subtract, so subtract that 48, and it leaves us with 80 equals x.
Wait, how did you get 128?
128, we had 2 on the bottom, we had to multiply it out of the denominator. That's what got us to 128. All right, 14, find measure of ln. That's that piece there. So I'm going to call that x. Now this one is on the outside of the circle. So now this is where instead of adding, we did what again? Subtract. So we have 96 minus x over 2. Again, we have the angle measure, it's currently equal to 20. So and we're solving. Get rid of that 2 again by multiplying it over to the other side. 6 minus x equals 40. Now that's a positive 96. How do I get that positive 96 over to the other side? It's already positive. I want to subtract. Now, it leaves me with a negative x on the side, and I end up with a negative 56. But then I just have to multiply or divide by a -1 to change my signs. So x is positive 56. All right. On 15, we have find measure of angle H. So same equation, but instead of writing it as an equation, we're just going to be simplifying on this one. So the big arc is 100. 100 minus 32 divided by 2. Well, that's 68 over 2, which is 34. On 16, now you have 2 lines intersecting inside a circle. And we're talking about the lengths of these pieces this time. How do those lengths compare to each other? What do you have to do? 3, I have 9, I have 6, I have a y. What do I do with those? What are you saying? Something saying something.
He said set them equal.
Set them equal. All right. Set what equal? All right. There definitely is equal.
6 and y and then 3 and 9.
6 and y and 3 and 9. So we're multiplying the 2 parts on one of the chords with the 2 parts on the other chord. All right. So we have 6 and y times 3 and 9. So 6 and y equals 27. Solve divided by 6. And that's 3.5. I'm sorry, no, not 3.5, 4.5.
Divided?
Yep, 27 divided by 6. Okay. 6 goes into 24 4 times, 3 left over, 3 over 6 is 1/2 or 0.5. All right, on AF. So this is a piece that they want us to find this time. Now, we have 2 secants. Now we have secants, we're using the exterior and the hole, not the interior. All right, so we never use the interior. So we need to make sure we find the hole. So 3 and 5 give me 8. On this side, I have 2 and x for x plus 2. So again, my equation, exterior 2 times hole, x plus 2 is equal to exterior on the other side is 3, hole was 8. Yeah, anytime you're dealing with the length of secants, it's the exterior times the hole. You can never use the interior by itself. So distribute on this side. 2 times these gives us 2x plus 4. 3 times 8 is 24. Subtract off 4 and you get 20. Divide by 2 and x is 10. All right. I'm going to go ahead and move this up before we do the next one because there's a couple problems dealing with circles. Any questions before I move this? Again, for circles, there's the formula. It was x minus h squared plus y minus k squared equals r squared. Center is hk
Hold on.
and radius is r. I'm just writing the information from our notes again. All right. So in that equation, they tell us find the length of the radius of the circle whose equation is this. Well, the 289 at the end represents r squared, right? So 289 equals r squared. We need r by itself. So what we have to do? Square root. We got to get rid of the square, so we square root. What is the square root of 289?
17.
17. That's it. Number 19. Find the equation of a circle with center 0, 0 and a radius of 4. Now, here there are a couple things that look like they might work. So you need to be careful. First, center of 0, 0. The values that are by the x and y should all cancel out. So it definitely can't be C or D. All right. The left side of the equation, or the part with the x and y, should look like that. Now, the radius is 4, but in the equation, what is the value that you're putting on the end?
Squared, right?
R squared, here, right? So on here, they told us the radius is 4, so when we plug it into the equation, 4 squared is 16. So which one's the correct answer? B. That's an easy one to get wrong because it looks so correct to do this one because you're like, oh, I got 0, 0, I got 4, there it is. And people get that wrong, one wrong all the time. Be careful, slow down. That has to be r squared. So we have to square the 4 first, and it should be 16. All right, the other one with the circle formula here. So we have h, we have k, and we have r squared. So my center on this one is at 3, -2. Remember, anytime you pull out the center point, the signs change because it's normally a negative in front of it. The radius on this one is 2 because you have to square root that in order to get the radius. So now, all those diagrams have a radius of 2, so that doesn't really help much. But the center, you have a center at 3, -2. Every single one of these is in a different quadrant. So there's only one in the right quadrant. We had a positive x and a negative y, and that answer was J. All right, the one down there that said bonus, again, this one was a little bit harder. You're not going to see anything like that on the test because this one ends up being a quadratic. Again, I am not giving you a quadratic on a test. So I'll show it. I'll show the setup. I'll work it out. But again, I want you to know you won't have to do this one on the test. So we have exterior, and then the hole on this one is x plus 1. This is an exterior. The hole is 14. So we're doing exterior times hole, 4 times 14, and x times x plus 1. The setup's okay. Nothing wrong with that one. We can even do the next step where we're simplifying. Distribute, you get 56 equals x squared plus x. This is where it becomes a challenge because now we have a quadratic. Again, not going to make you do quadratics for this, but what we will have to do it next year for algebra 2. So most of you have to go into algebra 2 next year. Again, you'll see it again. When you solve a quadratic, you could do it by factoring. So we could move the 56 over. So it's set equal to 0. Since we have a lead coefficient of 1, we could look for factors of the last term that add to the middle. In this case, that'd be 7 and 8. We need a negative number here, positive number here. So that'd be a -7 and a positive 8. Yeah. These two factors. Now, we would have to set each one of those separately equal to 0. If we set this equal to 0 and solve, we add 7 to the other side, so x would be a positive 7. This one set equal to 0, we subtract the 8, and we get a -8. You can't have a negative distance, so this one doesn't work. That's our only possible answer. 7 is the answer for that one. Again, there are other ways to do quadratics. You can do that. Graphing really isn't a good option here. You could do completing a square. You could also do the quadratic formula. Those are all different methods that you can use. Questions? All right. You want to do some on the other side of it?
Yes.
All right, let's keep going then. What time do we get out here? All right. Go as far as I can. All right. So let's clear that. Let's move this up. Like I said, this side is a little bit harder. The first side we did, that's going to be probably the level of questions I ask you. Again, there'll be a little bit of algebra, not a lot. So on number 1, they give you some length. They say they have the diameter of the first circle is 10, the diameter of the second one is 8. So then the radiuses would be half those. So this length, oops, I went a little too far there. This length would be 5. This length would be 4. And then they told us that AX is 3. So if that's 3 and this is 5, this piece has to be 2. If that's 4 and that's 2, this piece has to be 2 as well. They wanted YB, so YB is 2. On number 2, it says find the radius and diameter of a flying disc with a circumference of 11 pi. Again, I think I put 2 questions on the test that were in terms of pi. So you will see something in terms of pi. This one, we had 2 circumference formulas. Doesn't matter which one I use. I'm going to do diameter first because circumference equals diameter times pi. So this is 11 pi. What's my diameter? Pi on both sides. Divide it off. Those cancel. My diameter is 11. So that's my first answer. Second answer, I will need the radius. What's the radius compared to the diameter? Radius is 5.5. On number 3, they give us 2 equations, one for this part, one for this part. Well, these 2, they gave us equations for, those are vertical angles. Vertical angles are congruent. So what can we do with those 2 equations? Equal to each other, yeah. So x minus 22. And now I'm solving. Bring the x over. That's 2x. Bring the 22 over. That's 32. So x by itself is 16. Is it warm in this room? Or is it just because I'm staying on this board? Please, always put on some heat sun for a while. All right, so we have 16, that's our x value. Now, these angles aren't 16. We have to plug it in. So if I plug 16 in for that first one, that'll give me 16 plus 10, which is 26. So both of those angles are 26. Now, pick one of the 2 diameters. It doesn't matter which one you use. Let's say I use this one. Great. Everything on this side has to be 180 degrees. So I have these 2 that I know what their measures are. The one I'm looking for is this one. I need to subtract off the 2 that I know. 74 and 26 add up to 100. So 180 minus 100. This way. 80 for that piece. On 4, the diameter of circle C is 18 units long. Find the length of an arc that has a measure of 100. Round to the nearest 100. So again, this is arc length. They gave me all the values that I have to plug in. So the measure was 100. They gave me a diameter is 18, so I'm just plugging these in. So for number 4, we have 100 over 360 times 18 pi. Again, it's the fraction of the circle we're using times the circumference. So now, on here, I could simplify, or I could just plug this right into the calculator. Either way is fine. If you did try reducing this, let's see, you would have had 10 goes into each of those, so we can cross off a 0, right? So now we have 10 over 36. Both those are divisible by 5. No, sorry, not 5, by 2, I mean. We get 5. On the bottom, we get 18. Look at that. We have divided by 18 times 18. Those cancel off. So we just end up with 5 pi. This would be a great one to leave in terms of pi. But it said round to the nearest hundred, so you have to multiply that out. That's 3.14 times 5. That's 15.7. I guess we're almost out of time. Number 5, circle A. They gave us a couple of measurements here. These two, again, it's being bisected, so those should be equal to each other. Subtract the 5x, you get 2x. Add the 12 to the other side, that's 24. Divide by 2, that is 12 for x. That's our answer. 6, you really don't need to do that one. It gives you a quadratic, but then the x values cancel out. I can show the setup for it real fast though. We have PQ is 18 meters. This whole thing is 18. They told us that that little piece is 3. They wanted to know the distance from O to that line, so I could call that x. What would help me out here is if I knew a diameter, I could draw a right triangle. The trick here is we don't know the diameter or the radius, so we'd have to say this entire thing is 3 plus x, so this side is 3 plus x.
Press my wrapper.
I'll put the rest of the answer up on Canvas, and you can finish checking your work there. Again, like I said, you need about the level of the first review. All right. Same that. Same that.